Hi, this video will talk about how to find critical z-values, and I've got 3 examples that we'll go through. In the first one, you're given that it's a two-tailed test and alpha equals 0.08. So first let's draw and think about what that means. All right, you're going to always assume you have a normal distribution bell-shaped. Your alpha tells you your area in your critical region, okay? And so if it's two-tailed, you're going to have 2 critical regions. You're going to have a region there and a region there. And alpha tells you the area in here and the area in here, total. Okay, but now notice that this distribution is symmetric, meaning that the area here has to equal the area here. Okay, so when it's a two-tailed test, I'm going to take my alpha and divide it by 2 and know that the area over here has to be 0.04. Okay, and the area in here has to be 0.04. Okay, so that's why it's important that we know what tail it is. If it's two-tailed, you're going to take your alpha, divide it by 2. Now, what do we do with that 0.04? Well, we go to our z-table and look it up. Okay, so we'll talk about our z-table in just a second, but we're looking for an area of 0.04. So let's go to our z-table. Now the z-table is located in the back of the book and looks like this. Right here, we're looking at the negative z-scores. All right. You want to go to your z-table, and what you're going to do is look for 0.04 in the body here. Okay, so I'm looking for 0.04 in here. If I would have pulled up my positives, because there's a positive and a negative, you can see that within here, all the values are too large. Okay, so that I know to go to the negative because I'm looking for a 0.04. Okay, now I scroll through here and I'm looking, I see I have a 0.0427, 0418. The closest I can come to is right here, 0.041. Okay, now I go off to the left and that gives me my first 2 digits, minus 1.75. 0.7, sorry, minus 1.7. Then I have to go to the top. Okay, so we got the minus 1.7. And now I'm going to go to the top of this table to get the 3rd digit. And that's where the 5 comes from. So I know that my critical z-value on here is going to be, this is negative, minus 1.75. And because this is symmetric, this critical value here is going to be a positive 1.75. Okay, but if you want to look that up, you have a few other options. Okay, our table there that we were looking at is a left tail table. Okay, the area under this whole curve is going to always equal 1. And what that table gives me is always all the area to the left. That's why when I looked up 0.04, it gave me the critical value where the area to the left would be 0.04. But now if I want to know the area here, I'm going to have to look up the area to the left because it's a left table, but I want my area to the right to be 0.04. So I take 1 minus 0.04. Okay, it would have given me a 0.96. All right, if I want to look this up in the table. So now I'm going to look up 0.96 in my table. Okay, so now I'm going to go to the positive chart and look for the closest I can to 0.96. I see right here I have a 0.9599. If I look to the left, that gives me the first 2 digits, 1.7. And looking at the top of the column, okay, for where I had that, it would be 1.75. Okay, so there's 2 different ways to come up with this value. Once you find one, if it's a two-tailed, the other tail will be positive. Okay, so you can take the negative and positive. Or if you want to find the area to the right, you take 1 minus the area, which gives you 0.96, and look that up in the table. All right, so let's try another example there where we're doing a right-tailed test. Now for this tail, I don't divide by 2 because it's not two-tailed. What my alpha equals 0.02, that's an area or a probability. It tells me that I want an area over here of 0.02. Now the problem becomes my chart only gives me left-hand areas, okay? So I want to take 1 minus 0.02 and look that up in the table. That's going to give me 0.98, okay? So I go to my table and look for a 0.98 in the body part. So I find a 0.9803. It's somewhere right between these two. So I would accept 2.0. Okay, again, we find point somewhere right between these two. All right, we're going to look to the left. We know it's 2.0, but 2.0 what? So somewhere between 5 and 6. I guess technically it's closer to 2.05 because that's only 2 thousandths. Okay, so we're going to say 2.05, and that is your critical value. You're only going to have one because it's a one-tailed test. The easiest scenario is when we have a left-tailed test. Okay, alpha equals 0.10 means that I want this region here to be 0.10. I'm simply going to go to my table and look up 0.10. Okay, or yeah, 0.10. So I get here and I see that, let's see, 0.10, 0.10, I'm not even close, I gotta scroll down. 0.10, 0.10, let's see. Looking, and I see I have a 0.1033. Looking to the left for my first two digits, it's a minus 1.2. And looking at the top for my third digit, 8. So my critical value here is minus 1.28. So really we have three different scenarios. Two-tailed test, you take your alpha, divide it by 2. The easiest thing to do is to look up that number in the table and take both the positive and negative values. So your answer here would have been plus a positive 1.75 or a negative 1.75, and we write it like that. For the right-tailed test, you take 1 minus your alpha and look that value up in the table. And for a left-tailed test, you just look your alpha up in the table. So three different scenarios.